715 range module Leetcode question today. This is a hard question, and this comes in Google tag, companies tag, Google. Yeah, so there are other companies as well, but of course this is in right now. This is coming inside Google tag last 30 days. Okay, so what is the idea behind this problem? So basically this gives intervals like these, and you have to add an interval, remove an interval, query an interval. So for example, see, initially let's say this is empty, there's nothing. Then you want to add range, add 10, 20. So there is nothing, so you would just add it. When it says remove range 14, 16, so imagine if you remove 14 to 16 from this, what is left? 10 to 14 and 16 to 20, right? And then if you query 10 to 14, so 10 to 14 should be there, so this is true. But if you query 13 to 15, so 13 to 15, you have 10 to 14 and 16 to 20, right? So 13 to 15 is not there, 13 to 14 is there, 14 to 15 is not there, so this will give false. And when you ask 16 to 17, so 16 to 20 is there, so 16 to 17 is a subset of that, so this is there. So if this is not making sense verbally, then maybe you can try it on your own, read through the description, or watch other YouTube videos. This one is just for quick revision. So in quick revision, what are the approach? So approach wise, there are two approaches to this, multiple approaches I would say. So one is the segment tree approach, which I'm not covering in this video. I'm covering the simpler approach, which is very easy and very intuitive. So that way, first thing, we start with defining the interval. So what does an interval contain? Left and right? So each interval has a left and right, like here, left right like that. So just defining a custom class interval, and we are using a list of intervals to represent this. There are three functions to this, right? Add range, remove range, and query range. So add range, so basically in the constructor you are just initializing intervals to a new array list, and in add range, for every add range call you will get left and right, and you have to find the right position where that range should go. So initially, if this is empty, you can just add 10, 20 to it. But here there is no more examples, but if there are more intervals coming, then you have to find the right spot for it in the let's say in ascending order, I would say, like so for example, see what we are doing. So initially we traverse through the existing intervals, and we find the right position for the incoming interval. And how is it happening? See, so your left, the one that you want to insert, if it is more than the current interval, so you are traversing through the intervals list, and if what you want to insert is more than the current one, then you add the current interval to another res list. So basically you took a new res list and you traverse through the intervals, and you keep putting the new list, you form the new list by picking each interval from the existing intervals, and putting it in list, putting it in res, and along with the incoming intervals right place. So you are traversing through the intervals as long as the current incoming interval is beyond the current current interval. You keep adding interval here. As soon as you find that the one you want to insert is less than this one, less than the one you are traversing, then you insert the new interval here, the coming interval, and break it. There could be cases of overlap like this. So let's say left and right shows the interval that you want to insert, right? So if left is between the current intervals left and right, or right is between the current intervals left and right, then there is an overlap. In that case, you just keep updating left and right and add it at the end in cases like this. But one caveat is, if you break in between, then you have not reached n, right? And if you have reached n, then this one has not been inserted. If you reached n, this one has not been inserted, hence at the end you will add this. But if you are breaking in between, then you already add the incoming interval then break, so this case is not there. And if you break in between, then until you cover all the intervals, you add to res, and the new list res is assigned to the finite intervals list that we are maintaining. I hope this makes sense. If not, I know verbally it may not make sense, but this is for quick revision. For full detailed video, maybe I will post a link in comments to another channel who is explaining it quite well, and you can watch that. That's a half-an-hour video. Then for query range, so this is order of n, right? So you are traversing through the existing intervals list and finding right place for your incoming interval, right? And how you will find the right place? Just follow the ascending order of intervals. That's in short. Next, we talk about query range. In query range, we can do this by binary search here directly. And actually this one can also be done by binary search, but this is very simplistic that I have done. Especially in Python, I have seen in Python it gives you direct functions to find the right place, and the video that I will post, that link that I will post, follows that approach, so you can go through that as well. But this is very simplistic way of adding range. Now query range using binary search. Simple binary search logic that you do low and high, and taking mid every time. And if your incoming interval is falling beyond mid, then you do this, otherwise you do this. And if at mid, the interval at mid contains the left and right, then you return true. Otherwise, if this finishes at the end, return false. For remove range, this logic is quite similar to add range that I just covered. Just small differences so this one is quite similar. You keep adding the interval as it is. If you're left of the this one, the one you want to remove, is beyond this, you keep adding the interval to rest. And if you're in that case, also keep adding the interval, because in this case you just have to remove, right? So this is the case where overlap is there, so you will only remove when there is overlap. In all other cases, you just keep adding the interval to the new list res. And this is the case of overlap, where your left your range is falling in between some existing interval. In that case, if see this properly, so if your left is more than current intervals left, that means left and further is removed. So new range will have interval dot left to left. And if your right is less than interval right, then right and before is removed, so right to interval dot right is added. And at the end, again assigning back to this. And I hope this makes sense. This is again order of n, time complexity. This is faster login binary search. There are multiple approaches to this, but this is the one I quickly, and this one is quite intuitive to code. I hope this you don't get this question in your interview, because this could be tedious to code in small time. But that's about it. Maybe if I if I cover the segment, I may cover the segment tree approach later, if I find time, but this is a simpler approach. So in short, summary wise, 7.5 range module gives what is the idea. So there are a list of intervals. In that list of intervals, either you add range. For adding a range, you go through the existing interval list and find the right place for the incoming range, put it there. For removing range, similarly, go through the existing intervals list, and whenever you find an overlap, you decide the new intervals to add to the new list. And for query range, you just do a binary search and find the right interval which has an overlap with your left right, and in that overlap, if your left and right is a subset or subset of that interval, or fully that interval, then you return true, otherwise return false. Hope that made sense. I hope I took already 10 minutes. So okay, thank you, bye bye.